If you take the limestone cliffs in the UK, which are a very classic example, effectively what nature has been doing over millennia is storing carbon dioxide through a natural process of carbonation for millions and millions of years. The only thing that we've sought to do, and which a bunch of very brilliant professors who founded Carbon8 Systems managed to do, was to take that process, which takes approximately 15 minutes in our case, where nature takes, probably several millennia, and we capture the CO2 directly from the flue stack into the container. And then, if you can imagine this on a conveyor belt, you have as well the thermal waste residue from that operation, which comes in parallel, and the two are brought together through a series of steps and exposed to different elements and processes to effectively perform the ACT, so the accelerated carbonation technology, and to produce on the back end what is frequently referred to as an aggregate.
Welcome to Mindful Businesses, presented by Sarani, and I'm your host, Vidya Iyer. In our podcast, we bring to you brands that are mindful in their practices and processes. A mindful business adopts and employs sustainable social, economic, and environmental practices. Today we have with us Maarten Van Roon, Chief Commercial Officer of Carbon8 Systems, making carbon productive. He joins us from London, UK. Welcome, Maarten.
Thank you very much, Vidya. It's great to be here.
So when we think about carbonation, the first thought that comes to my mind is, what is carbonation?
Effectively, what carbonation is a form of CCUS, and CCUS is a form of permanent carbon capture. So I think the terms that you will see floating around a lot when you read articles in the media or television in all of the sustainability advances and innovations that you see, we talk about CCS a lot, which is carbon capture and storage. The terminology, which is probably you see less frequently, but which we'd like to see a lot more frequently, is CCUS. And that's all about utilization. It's about carbon capture and utilization. Mm-hmm. What carbonation is that carbonation and mineralization are a form of CCUS. So effectively, what we do and what carbonation is, it's permanently sequestering and storing CO2 within a physical compound that can then subsequently be reused again, and hence the U in the CCUS.
Why is it so important to capture it?
I mean, if you look at the variety of different industries, and one of the ones that we're focused on particularly is the sector of hard-to-abate industry. So if you look at, for example, the cement industry, which emits some 8% of global GHG, I think sometimes what we underestimate is that even though carbon, gets a bad reputation at the moment, carbon can actually also really be used as a very useful compound, certainly in the circular economy, and for making certain products useful again. And we apply that specifically to waste. Mm-hmm. And so it's a way of capturing GHG emissions, which would otherwise end up in the atmosphere, and making those carbon molecules from CO2 useful again in new recycled building compounds, in our specific case.
And when you say GHG, you mean greenhouse gases?
Yes, correct.
But nature has been capturing carbon for millennia. How does nature do it?
It's very similar. So it's effectively the carbon molecules reacting with, in this case, if you take the limestone cliffs in the UK, which are a very classic example, effectively what nature has been doing over millennia is storing carbon dioxide through a natural process of carbonation for millions and millions of years. The only thing that we've sought to do, and which a bunch of very brilliant professors who founded Carbon8 Systems managed to do, was to take that process, which takes approximately 15 minutes in our case, where nature takes, probably several millennia to do the same thing. So we're very much mimicking nature in that sense.
You talked about the cement industry. So which other industry or product or activities can be used to capture carbon?
I can speak about that. I'd probably, in order to give a good overview to you and your listeners, I'll probably take us one step back. And when I talked originally about CCUS being, and carbonation specifically, mineralization specifically, as a solution for GHG emissions, I think if we take a step back and we look at some of the hard-to-abate sectors like cement, but equally industries like the biomass industry, or we look at energy from waste, or we look at, probably in our specific case, any industry which produces thermal residues, so waste streams, as a result of combustion, usually of a fuel. In the case of an energy from waste plant, it arises from the combustion of household waste in many cases in order to generate electricity. In the case of a cement plant, it's frequently the use of alternative fuel firing systems, which leave behind a residue as well. And those residues, which in this case would be landfilled, both at an impact economically in terms of cost, but also in terms of a natural impact to the environment, those type of waste streams are ones that you can carbonate and effectively re-inject with CO2 as a form of permanent storage, so more than 99 years, and subsequently use again to enable the circular economy and generate new building materials that can be used again.
What is the pH level of this new product?
I think it depends very much on what the source is of the residue that you're using. And that is very different between industries, but it's also very different in between specific customers and producers. It all depends on what the residue is originating from in terms of a fuel source that's being fired.
So Maarten, when did you join Carbon8 Systems?
Well, actually only very recently. So I've only been with the company now just over 6 months. But I was actually employed at Royal Dutch Shell, the oil and gas major, for over 16 years.
And it's a complete contrast, right? What made you switch from the gas industry to a more sustainable industry?
So a very interesting one. I don't think it's even so much in the space of on which side of the, I suppose, carbon equation that you sit. I think it's more rather I was involved in my last role at Shell really working with startups. And a lot of those startups were in the sustainability space because, as I'm sure you're aware, meanwhile, the oil and gas majors are very heavily invested as well into finding new sustainable solutions to problems. But I was in a role in which I was, during a period of time, exposed in working with a large variety of startups in the sustainability space. And I thought that just the amount of energy and passion in that space was just incredibly infectious, and found myself, really at some point wanting to say, well, you know what, actually, I'd like to spend more of my time in that atmosphere and in that energy and with this, in a smaller scale enterprise, but with a lot of passionate people around me looking at sustainability solutions. And I decided to take a leap of faith. I think it took me a while to make that decision, but I'm incredibly happy that I've made it, and I feel incredibly comfortable meanwhile where I am.
How did you come across Carbon8 Systems? How would you introduce to the company?
Yeah, so it was during a period actually where I was in the process of looking at a variety of companies for a project that we were doing. It was not one of the companies that we ended up engaging with, but it was one of the ones which looked quite interesting. And then I ended up sending a message effectively to one of its members, and there was a discussion that ensued and to become part of the conversation. Mm-hmm. In parallel, that company was looking to recruit someone to its executive management committee and for a chief commercial officer position. And I decided to apply, and the rest is history.
You started working with Carbon8 Systems fairly recently, but the founders are researchers, professors. Who are they?
So our company was originally founded by Dr. Colin Hills and Dr. Paula Carey, who are two leading geologists, I think globally recognized as leading geologists from the University of Greenwich here in the UK. They invented the ACT technology, which is accelerated carbonation technology for short. And they founded the company in 2006, whilst they were still working in academia, when they invented this technology to effectively speed up nature's work in the form of carbonation and mineralization. That's been going on since 2006, but the company has gone through several different iterations up until the point where we are now with a very modular mobile solution, which is a TRL 9 level technology, so ready for commercial deployment and in operation with customers around Europe at the moment.
Took almost 15 years from Eureka moment to actual commercial deployment. When was the company started?
So the first commercialization of the technology was back in 2006, which is when the first company was founded. And it then went through several different iterations. I mean, the actual technology has been in operation at 3 plants under license in the UK already for many, many, many years. It's only really that we started looking at the global landscape for the technology when the company managed to effectively encase the ACT technology in a mobile modular platform, which currently sits in two 40-foot containers that we can actually ship around the globe, and in an almost plug-and-play fashion attached to players across the cement industry and some of the others which I'd mentioned previously.
If you step back a few years before the incorporation of the business, how did they transition from being geologists to being innovators in the energy field?
I'm not sure I could speak on their behalf, as they'd probably be far better positioned to answer that question than I do. But what I believe, I know both of them meanwhile better and better, and I have huge respect for what they've done over the years, is I do think that if you are the inventor of something ultimately which you think will do good in the sustainability space, in order to maximize the effect that you can have or the impact that you can have, even on a sustainability space, I think that route has to lead through commercialization, investment, and deployment in order to really, even if you're looking for a maximum sustainability impact, I think that's the route to achieve that.
We often have so many researchers who do not see value in commercializing. It's because they are focused on their research. There are different sets of skills which are required to bring their research to market. How did these two researchers decide to bring their product to market?
I mean, in the current iteration of Carbon8 Systems, I think the decision was really very much in the context of what I just provided in terms of, having maximum impact. And then I think following on from there, bringing in a certain set of skills and competence from people who had been in industry for a long time, such as our CEO, John Pilkington, who's been, active across several enterprises within senior functions in the asset management and building industry, as well as myself with a background of 16 years in Royal Dutch Shell. And so I think that's when that transition happened.
It is amazing that they were persistent for 15 years to get this commercial venture going and have these 3 plants set up.
I would definitely call both of them very passionate and very persistent. I mean, I think in a broader sense, the way that I always try to look at technologies and innovation into a new space, I like to think of these in terms of 3 clear buckets. We look at desirability, we look at feasibility, and then we look at viability. I think it's quite a classic model.
Mm-hmm.
I think the first question you need to answer is this desirable, right? So who wants this? Who does this help? And with whose agenda or ambition does this fit? That's the first question you'll have to answer. And then you have the 2 separate pieces, which are viability and feasibility. And feasibility is very much frequently, at least in our space, in the technical sense. So can you actually technically accomplish what it is that you seek to do? And not just in the lab, but can you take it out of the lab and into the field and prove that it works? Mm-hmm. And then I think lastly, if you want to scale that, then you need to have a viable approach. So you need to deploy a business model which is effectively investable, that can attract investment and that can show profitability over the longer term so that you can really scale up a business and deploy the technology across the globe with customers.
So let's talk about the technology, the ACT, accelerated carbonation technology. Walk us through the steps. What exactly happens?
Effectively, what we do in the technology is we introduce the waste stream, that is the stream of material in which we would like to sequester the carbon dioxide. And the great thing about the innovation that Carbon8 Systems has is that we have the ability with a container to plug in directly into a flue stack. So that is, for lack of a better term, I suppose, the chimney, which is emitting the CO2 in a production plant in cement or energy from waste or others. And we capture the CO2 directly from the flue stack into the container. And then, if you can imagine this on a conveyor belt, you have as well the thermal waste residue from that operation, which comes in parallel. And the 2 are brought together through a series of steps and exposed to different elements and processes to effectively perform the ACT, so the accelerated carbonation technology, and to produce on the back end what is frequently referred to as an aggregate.
If we focus on the cement industry, what are the temperatures that the lime, the key component of cement, is heated up to? And how much CO2 is released in, say, a production of 1 ton of cement?
That's an excellent question. In terms of how many tons of CO2 are produced from a ton of cement, I think is very specific in terms of, what the sources of the ingredients, from how far away they come, what carbon footprints they have, and then the actual fuel firing process behind that, whether it's using alternative fuels, whether it's still using coal or heavy fuel. So that it's difficult to give a precise reading on that. But certainly the CO2 temperatures frequently can be very hot. So in terms of degrees Celsius, it can range anywhere from, I think, around 50 degrees Celsius to several hundred degrees Celsius. So those temperatures can be very hot.
This carbon is captured and you create products. Give us an example of the products that are created.
Probably the best example I can give within the cement industry. So we take the thermal residues, which are also referred to as bypass dusts, and those bypass dusts we use to carbonate with CO2. In doing so, they produce an aggregate. And an aggregate is effectively very much like you imagine effectively just very small stones or expanded clay in terms of sometimes you have in a flower pot. There are these clay stones which are expanded. That is very much what the material looks like. I would encourage anybody to go and have a look on the site. Mm-hmm. But effectively, the carbonation process hardens the material and forms it into chunks. The container system is also designed to produce those in a specific format and a weighting, and you get as a result what we refer to as a lightweight aggregate product. And that lightweight aggregate product has many different application possibilities. We see them being used in, for example, making new cement blocks and bricks. You could make use to make houses, walls, etc. You could also see them used in things like substrates for green roofs, which are popping up over many urban areas. We are in the process as well of testing the material in application for fertilizer. So there's quite a whole host of different application areas you can use the materials in. And I think as we go forward, we continually seek to unblock and be technically approved in new applications.
I wanted to take a moment to distinguish between cement and concrete, which are often used in the same context. Cement is the product, and when you add the aggregates, that creates concrete. The aggregates are sort of the glue, which helps you create concrete, which can be made into our walls, our bricks, or blocks.
Correct. And the aggregates, I think, that you use, they're very frequently recipes owned by the companies who make those end products. And, the use of aggregates has different functions. One of them is obviously to determine the characteristics of the final product in terms of whether water resistant or not, whether it lets water seep through. So a brick for a house will be a very different mixture than brick on the pavement, etc. And the aggregates, they form a function of those.
So have you tested your aggregates for different applications?
Yeah, absolutely. So they're currently in use. I think the first strategic customer that we really managed to convince that, this was a pathway to sustainability is a French cement group called Vicat. Mm-hmm. And one of their flagship sites in France is in Montalieu. It's in the area of Lyon. And our innovation has been deployed there since the earlier months of 2021. And that product is being actively used currently in making new cement and blocks and ultimately concrete.
So that's pretty incredible that you take heat from one process and the waste from that process and create a useful product.
In a nutshell, what we do is we upscale effectively landfill residues or residues which are otherwise destined for landfill. We avoid that waste and we use CO2, which can be either directly from the flue stack or bottled, and we permanently sequester that CO2 in that waste stream. And in doing so, we build valuable new products which can be reused. And in doing so, effectively, we like to say that we enable circularity in that process.
You use the word permanently capture the CO2. Is it for infinite time, like into infinity?
Yeah, it's a very interesting question as to how that's defined. I think permanent sequestration is defined as anything which is longer than 99 years. And once the CO2 through carbonation and mineralization is housed within a new compound, like a thermal residue or a waste stream, yes, unless the material, there's no real way of the CO2 escaping that material again, unless it's under extreme conditions like several thousand degrees centigrade of heat or pressure, etc., but events which don't really ever occur. So as a result, we're very confident in saying that permanent sequestration in this case means that the CO2 will be stored in the material for a minimum of 99 years.
And what you're saying is that unless there is a human intervention, that you take this and you possibly heat it up to the thousands of degrees, again, then maybe the sequestered carbon could be released.
Yeah, in a near unimaginable scenario where you would expose the material to that, which I suppose you would never do voluntarily because I couldn't imagine a reason of why you would. But yeah, if you get up to temperatures, close to the levels, found in volcanoes, then you will end up releasing the CO2 back in the atmosphere. But that, I think, is incredibly rare for that to happen.
So let's talk about your commercial solution. Give us a visual. Like the way I visualized it, we have a smokestack in a cement factory, and you are placing your containerized solution there, which is capturing the CO2 and putting it in the waste residue from the cement factory.
As you can imagine, is we have our container. I think you'd probably be easy to find a picture either from our website or from the media outlets. And effectively, it's two 40-foot containers, which are stacked on top of each other. And the entire process of carbonation and mineralization, ACT in our case, is housed within those. One side of the container is directly connected to a flue stack through a series of pipes and connections. And the other part is connected to usually a reservoir which contains the thermal residues which are produced on site. As a consequence of combustion, and they both go into the container. The ACT batch process takes around 15 minutes to a half an hour, and every batch that is released then subsequently through a pelletizer, you get these aggregates which are carbon negative, basically as compounds rolling out of the other side of the container and ready for use.
So right now you are using it for like big applications. Is it possible to make it more, can it be scaled down, or do you need this volume for it to be viable?
Yeah, I think already the solution in itself is destined. It's relatively small in terms of the amount of space that it takes. If you compare it to potential future competing technologies like a CCS plant, then it's certainly a lot smaller. Typically, we like to treat anywhere between 10 and 12,000 tons of residue per year with one container. That means that usually depending on how large the cement site, of course, is and how it fires its alternative fuel systems, frequently either one or small number of containers would be capable of effectively removing the entire thermal residue waste from the site and carbonating it with our technology. So if it can be scaled down from that, probably it could. I'm not sure what the economics of that would be. And one of the things I think which has really helped us going forward is because the system is modular and already smaller in scope, in size at least, you see that it is actually quite economically profitable to run one of these systems on site just because of the amount of landfill cost that the system avoids. Every single time you do that, depending on which geography you're in, we see anywhere of levels of 30 to 50 US dollars a ton, sometimes in markets like the US and Canada. But then if you move across to Europe, that fee goes up, probably closer to $100. But then if you go to some of the geographies which are really already, let's say, walking the walk, and I take South Korea as a very specific example, then you see that the landfilling costs for some of these residues are probably well north of 200 US dollars a ton. So it's incredibly economically viable to do this.
And these products that are created, are they then sold to people, or are they just used back in the same industry?
I think it depends per industry, but in cement, there is a direct use for the material. Frequently, there's a direct use for it on site in an integrated fashion to put back into cement or into blocks, depending on how integrated that site is. In other industries, which are less adjacent to the building industry, like, for example, energy from waste or biomass or even steel, you see that the material gets sold into adjacent industries and is sold for positive economic value.
So basically, instead of paying for landfills, they are actually getting some income, some revenue to offset their costs.
Yes, absolutely. So the idea is, I think in a headline, and it features on some of our slides as well when we go to customers, is, we turn liabilities into assets. So we take the waste liability and we turn it into a valuable product,
If you had to put a number on the impact of your accelerated carbonation technology in reducing the carbon footprint, what would the number be?
It's incredibly difficult to give a specific answer, but I will try my best to try and give you a little bit the scale of what we do.
So let's pick just one project that you have implemented, right? And just take that project and say, if our solution wasn't there, this would have been the impact. And now that our solution has been implemented, this is what we have done.
So I would take the case in the example of our strategic customer down in France, where we convert 12,000 tons of residue, which is normally destined for landfill, which has a carbon footprint, both in terms of getting up to where it has to be landfilled, as well as once it's landfilled. And we use that product and we probably carbonate anywhere between 10 and 30% of CO2 into the material.
Mm-hmm.
So if you're thinking about 12,000 tons, then you're looking at anywhere between 1,200 tons to probably 3,000 tons of carbon dioxide, which we sequester into the material annually. The licensing contracts that we work with in our business model, they last for 10 years. So if you extrapolate that over a 10-year period, then the innovation will be responsible for sequestering, many thousands of tons of carbon dioxide and diverting probably even more thousands of tons of residues away from landfill where they would have been destined.
Mm-hmm.
As a last bonus factor, I suppose, all of the aggregate that you then make, which would have otherwise been virgin aggregate to start with a far higher carbon footprint. I think if you add all of those different sources of, I suppose, environmental positive impact, then I think the effect is quite big. I wouldn't feel comfortable quantifying it just off the top of my head, but it's significant.
What is your business model? Is it like a turnkey project, or is it that you give the technology and the map and I go pick my things and do the application? Say I'm a cement manufacturer.
So I think where it starts is that, and we have these calls a lot at the moment, so people enter our commercial pipeline and we have an initial set of discussions around what type of residues and how much residue somebody produces in an annual period. And then frequently what happens is that we receive a sample of those residues and we test them in our laboratories to see how much CO2 we think we can store in those materials.
Mm-hmm.
And upon doing so, we build a business case for the customer. We look at their landfilling costs. We look at how much CO2 we could store in the materials, what their alternative values are for CO2. And then we look at the local aggregate market in terms of geographically where the customer sits. And we put together a business case for the customer that says, this is how much value we think we can provide with this innovation, both in terms of sustainability. We have some LCA models as well that we work with.
Mm-hmm.
But certainly also economically. And frequently what we see is that the container, which is spelled CO2 and then entainer, as you've probably seen.
Very cute, very cute.
Thank you. And I think in most cases what we see is based on those values and what we charge, we see payback periods of anywhere between 12 months to 36 months for customers in terms of adoption, which is, certainly in the cement industry, I would consider that highly profitable.
Your products are implemented in Lyon and where else? In Korea, you said, or no, not yet?
So Korea is an incredibly interesting market. I think that we will in the short term be deploying in Korea, but we have not yet. We've done pilots in the Netherlands, specifically in the energy to waste segment. And we've also done a pilot in Canada in the cement industry. I think that we will be deploying across Europe and the US and certainly parts of Asia across the industries in the next 12 months.
Yeah, how about the emerging markets like India, where growth in the construction market is far more than established countries, shall we say?
That's a great question. And that's probably a question that we face internally a lot in terms of where we focus our attention. I think certainly if you look at reservoirs of residues that remain through, which have been produced over time, then in some of those countries, which are big industrial producing nations, have very large stores of materials that you could carbonate. I think one of the challenges we sometimes face is that I think the regulatory environment is still quite different. And where the regulatory environments in places, probably South Korea on the one extreme in terms of how tough they've really cracked down now on emissions as well as on waste, but also Europe to a lesser extent. I think the regulatory environments there stimulate the adoption of the technology in an economic sense, probably more. But if you looked at in terms of a total sustainability impact that you could have, absolutely and certainly that's where we're going to want to deploy in a massive way. I think as well, probably one of the other specificities which I've learned over many years of doing business in a global sense is that we're just starting out. We're in the process now of completing a Series A, deploying with strategic customers, and really, I think at the tipping point of really deploying the innovation everywhere across the globe.
Mm-hmm.
And what you find is that certain markets which are either closer to you geographically are easier to access. and then certain larger geographies elsewhere around the globe, specifically developing upcoming countries or developing countries. And what you see there is that you need to choose a really strong local partner to work together with people and do things in a joined up fashion. But I think that getting to the point where you make that choice in terms of which market you want to go to, which partner you choose, and how you implement, you need some time to do that. And unfortunately, one of the big issues that you face in any startup, I think, is you're generally pretty underfunded and under-resourced. And so you have to pick your battles quite wisely in the beginning. But it's undoubtedly that we have the ambition to go to India and to China and to deploy the technology there over the longer term.
How much funding do you guys have up to now?
Currently finalizing our Series A, and we will be raising an amount of funding which allows us to really go and deploy at scale globally. And up until now, we've been funded by both the university as well as a private investor, as well as several of our founders who have at various points in time in the company's history made investments into the company to bring it to the point where it is today.
So remind me again, do you capture all the carbon in the cement plant?
No, we don't. I think the total amount of carbon dioxide, again, which is emitted by a cement plant, is hard to define in terms of scale and fuel usage, etc. But no, we don't. What we pride ourselves on is the fact that we can remove the waste and that we can permanently sequester the carbon that we can house within the waste through the ACT technology. By no means do we capture all of the CO2 coming out of a cement plant. In fact, we capture probably a relatively small percentage of the total CO2 emitted by the plant.
Who are your competitors in this technology, and how are they different from what you do?
Yeah, that's an excellent question as well. And we get asked that both by clients as well as investors, as well as potential partners going forward. It's difficult to answer just because in terms of, let's say, TRL9 level technologies, which are ready to go, which can be sold tomorrow and which can be implemented on a site tomorrow, there's very few pieces of technology that can offer that tomorrow.
What is TRL9?
It's technology readiness level. So it's a classification and a standardization which is used in order to classify how far technologies are along, TRL1 being sort of at very conceptualization phase and TRL9 being really ready for full commercialization. So anywhere on that scale in terms of readiness level. And to that effect, there are very few technologies. There are a lot of really exciting technologies coming up, which are not yet at TRL level 9. And at the moment, to be really frank, even the people that are coming up, I think, and the technologies which are coming closer to TRL 9, I don't think anybody sees each other as a competitor in this space, because I think it's going to take all of our combined efforts to, first of all, get acceptance for the technology itself, for its acceptance as a sustainability driver for customers. So I welcome any colleagues in the market to help us drive that mission forward. And I think it's going to take all of us to have an impact.
But your technology is patented, right?
That's correct, yes. So the ACT technology is a patented technology.
While you were describing your application, I thought of this one application. Maybe I'm completely wrong. There are garbage dumps which are on fire for years on end. I know there is one such in Bombay, India. Could you capture some of that?
I'm not sure whether you could capture the CO2 which arises from those fires, because I think that seems like it would technically be quite complex to do. But I think certainly that, some of the thermal residues and certainly the soil in which some of those contaminants land, and those contaminated soils, they could be remediated through a form of carbonation. So yes, I think definitely on that front you could. Mm-hmm. And I think actually interestingly, and I didn't mention this in the history of the company, but actually I think one of the initial spaces where our founders and the scientists started researching was in soil remediation. And so actually remediating soils which were contaminated through a form of carbonation and mineralization. So you could certainly apply that to this principle, yeah.
Your technology is new. It is unknown. Your outcomes that you say that you will offer to a company is what you say. How do you get customers to believe you? How do you acquire customers?
That's a huge challenge. I think it's a challenge for any startup. It's no different for us. You face the ultimate problem of credibility. And that lack of credibility stems from the fact is that nobody knows who you are. And if you're coming with a new technology, most people don't know what the technology is. Mm-hmm. You don't have, 20 years of reference that you can base yourself off of. And so you probably have to speak to a lot more potential customers than you would otherwise in order to secure one which is willing to take the leap of faith with you. I think the type of customer that you have to find frequently is that typically what I've witnessed across the industries that we work in is that the really big guys are frequently not the first ones to move. But the really small guys either lack incentive or, the ability to acquire your innovation. But somewhere in the middle section of most markets, there are, the companies which are smaller than the big ones, but that have to try new things in order to keep the really big guys awake. And these are the companies that frequently, especially now, will try to diversify themselves in terms of sustainability, and they will try to potentially acquire pieces of technology or try new processes. Their appetite to try something different in order to differentiate themselves from their bigger competitors and their smaller competitors. In that sweet spot, I think, is where you find the customers which are willing to take a leap of faith. And then sometimes that ends up being a family-owned business who perhaps has different drivers than a large stock-listed company does. I think you have to find your customer. But that is a very energy-intensive process, and you have to speak to a lot more people. But it's a bit, I always try to tell my teams as well, is I think it's a bit like sheep. So, I think it's once you push the first one over the edge, then the rest will follow a lot easier. But I think 60 to 70% of the effort is probably in getting the first few customers, and the rest hopefully will follow.
So who was Carbon8's first customer?
Probably not the first one we did a trial with. So if you take the trials away, so who do we have our first real longer-term commercial relationship with now, is certainly Vicat in France, so the French cement producer. One of the things that you see, which is, I think, quite interesting in sustainability, is that it's still very difficult for large corporations to digest sustainability deals. And not so much because they don't want to, or because they're not motivated, or even that they don't have the money to spend on it. It's got nothing to do with that. It's just that sometimes the processes and the structures that are in place are not specifically designed to digest these types of deals.
They can't pivot very quickly because they're so huge, they're so optimized. And to say, okay, fine, you know what, we're going to put this thing and right now make our own aggregates, for instance. It's not easy enough. They're not agile enough to do it.
Yeah. And it can be sometimes as simple as, the structures which are in place. So if you look at a traditional company that produces a product, well, it's...
Sorry, when you say structures, you mean physical structures or management structures?
Processes, no, internal structures, corporate structures, management and corporate and decision-making structures, I think more so than anything. And specifically because the way businesses in their respective industries consider investments either in new technologies or in new pieces of equipment are very much based in terms of value streams around what they know how to do. If you introduce something new into that, it's not so much that they don't want to do it or that they don't have the funding to spend on it, is that they don't know how to digest the deal internally in the governance structures that exist, because sometimes the value streams from these type of innovations are very different from the more classical value streams that they're used to dealing with.
Thank you, Maarten, for coming on the show. It was a pleasure to have you on Mindful Businesses.
Thank you, Vidya, and I wish you all the best of luck, and I look forward to hearing more of your shows.
This is Vidya Iyer with Mindful Businesses. If you're a creator of a mindful brand or would like to recommend a mindful brand to be featured on our show, send an email to info@mindfulbusinessespodcast.com. Subscribe, rate, and review us on Apple Podcast. If you learned a thing or two from this episode, share it with one friend. We recorded this podcast in Lafayette, Indiana. Theme music composed by Tatum Gale. Marketing assistant is Caitlin Milligan. Advisors are Jim Stone and Anupama Purusha. This is Vidya Iyer with Mindful Businesses.